So today we will look at our SDN Lab, where you see this controller that is talking to not only the network, the router here, but it's also talking to the applications, and therefore it's making decisions based on or programming the network and the applications based on how the network and the applications are behaving. So a quick demo or just a quick overview before I give you the demo. There's a client right here that is coming in from the internet, and he's trying to reach this Anycast address 100.111. Now the reason I call this is an Anycast address is because any address that gets advertised from more than one place is an Anycast address. So in this case, this Anycast address is coming from North American data center and South American data center, and the controller is connected in Asia with the router that's connected to the internet. So he's going to be talking to this address, and this address is essentially an application, a web server that is sitting across the world, different places. In our case, it's just sitting in 2 different places. So when he hits the router is going to make the decision where to send this flow based on what the SDN controller is going to tell him. So the SDN controller, the first part, we're going to do a load balancing between the 2 applications, and we're going to do this by round robin. So round robin basically is you send the first flow to the first application, then second flow to the second application, and third and fourth and so on. So you switch between the 2 on a round robin basis. And then when something goes up, like the load becomes higher on this guy, you just switched to the second one until the load equalizes. So the logic that I've written inside the SDN controller is to round robin when the load is equal, and when the load is higher on one server, you basically go to the second server consistently until it becomes lower. So that is the logic that I've written. It's a very simple bash script that goes in it, and it's talking to the applications. Having said that, let me give you the overview. So this guy right here, VOS1 is the client, and he is going to be running a script inside him that will tell you whether it's web 1 or web 2. So this is my web 1 right here, and this is web 2. So if I run the script right now, he's going to web 1. Now I'm going to turn on the SDN controller with the round robin logic, and it's going to start doing round robin. So here's my SDN controller right here, this guy. So I'm going to say SDN logic, and he's saying, okay, you're going round robin. And once he says that, look at this, it's coming from web 1 to web 2 now, and it's going to constantly switch web 1, web 2, so the flows are going between web 1 and web 2 now. Now I'm going to open up VOS2, which is my BGP router right here. And you can see that the BGP controller or SDN controller is constantly switching the route. So right now it's 24.0.0.100, which is this address right here. Now it's going to switch 24.0.0.100. So if you keep looking at it, there you go. Switch from 24.0.0.100 to 23.0. So it's basically switching, it's changing the route based on the load on these servers. So I'm just looking at the loads on these applications, and that's how the applications are talking to the SDN controller. And it's basically switching the load between them. All right. So now what I'm going to do is I'm going to increase the load on this guy, and you'll see what the controller will say. And I'm going to do that by simply SSHing into 100. And I'm not sure where it's going to go. It could be going to Web 1 or Web 2. So I'm just going to do, actually, I'm just going to do a command that would there it is. So this command is basically going to open a SSH session, TCP session, and on this address, whether it's Web 1 or Web 2, wherever the flow is going, for 3 seconds. And when it does that, you'll see some messages here saying from round robin, switch to Web 1 or Web 2, and you'll also see the result here. So let's see. Let's see if it changes. Sometimes you just have to do it multiple times to make sure the session gets higher. There you go. It says move to W2 Web 2. So this is when we open this session, it basically went to Web 1. So we'll move to Web 2 until this session expires, and it's going to start round robining again on this. So it's moved to W2 Web 2. If I open it, another session is just going to go to Web 2, and it's going to become round robin. So now it should go move back to round robin. And let's do it one more time to see if it switches. There you go, it switches back to round robin because now the load are, and you can see the same thing here. It's now going round robin. So it's simple SDN logic that's programming the router to send the flows, and it'll also check the pulse on the web server. So if I have this web server right here, so right now it's on Web 2, whichever server it's on, we're going to pause it. So it's the SDN controller is keeping a pulse on both the web servers to see if they're up and running and what their load is. So here's the web server 2 and here's web server 1. So we're just going to pull them down or just pause them and see what the SDN controller tells us. So let's go, he's on Web 2 right now. So this is Web 2 right here. I'm going to pause this guy. Let's see what this guy says. So this guy is saying that W2 is down, now it's taking to W1. So it's, see, the SDN controller is not only programming the network and keeping a pulse on that, it's also checking the servers to make sure they're up and running. Let's bring it back. And it should say move to W2 again. So this is how the SDN controller, without sitting in line, doing load balancing between the applications. And so a typical load balancer would actually sit in line, and you know your servers are going to be behind it. here this guy is sitting not in line, and he's just programming the network. The load balancers do not program the network. They just look at the pulses or look at the metrics at the servers and then sends the flow accordingly to the appropriate server. Here, the SDN controller is programming the network based on what he's getting the feedback from the network as well as the application server. I'll show you the SDN logic that I have built to do this. And if you are comfortable with Bash scripting, then you may be able to grasp it, but I'll encourage you to take a snapshot of it and look at it. I'll go through it line by line. The script basically is this. I've got the SDN logic script right here. And I'm talking to the Web 1 and Web 2, capturing their TCP information from them. So basically, if you do look at the W1DXT, it's basically the number of TCP connections. And then what I'm doing based on that, Web 1 has 7 connections, Web 2 has basically, I'm curling it from them. And then once you have that, I am using that information in my SDN logic to make a determination. So I'm putting this in a loop, and then I'm saying ping the first server and a count of 1, put the output, suppress the output, and if it's greater than 0, basically if it failed, then move to the other server. And I'm using the ExaBGP BGP controller to announce the route to other servers. So if the ping fails, I move to a different server. 23.100 fails, go to 24.100, and then just echo, and then get the information from there. Same thing with the other server. I'm just pinging it. If it fails, go to the other server. This is the round robin. If it's not round robin, so I mean, this is just to make sure that these servers are up. Then if that is all good, then what I'm doing is I'm curling the TCP information from those servers. I am comparing those TCP connections, and then I'm saying if they're greater, then go to the other one. If they are equal, then run a round robin script. And the round robin script is also pretty simple. It's just announcing the route to the other server every 2 seconds. So this is not in a loop, but this script itself is in the SDN logic loop, which goes every 3 seconds. So here is a demo of the SDN Lab where you have successfully load balanced and did a failover to the servers, and you can do the same thing with the routers. If you have multiple routers, I just kept it simple for this demo. If a load on the router gets excessive, you can move the load to a different router if you have multiple routers here. And you can look at this guy. I just did a simple script to packet load on this guy here. Sorry, router 2. Drop into bash shell. You can write scripts here. Packet load. You can extract the packet of any interface. So in my script, I'm looking at, if you want to run this packet load thing, let's look at the Ethernet 1 for every 2 seconds. And then I'm going to increase the load on this guy. Let's make it higher. There you go. And so you can look at these, load numbers, extract them, and make a SDN logic to make a programmatic decision on the SDN controller. And you can, curl these. These are web servers, so you can curl this information on the web server. Basically, what I did was that I can open my web server. Here it is. So if you look at the web server, what I'm doing here basically to capture the TCP connections is here's the default web directory var www.html. So I am basically curling. Here's my methodology of capturing the TCP connection. So I'm putting in a loop. I'm basically saying I'm using an ss-s command, and I'm grabbing on the second column to grab. Here's what you get with ss-s. You get the TCP connections. I'm just putting that in a variable first, and then I am echoing that into a file, and then I'm grabbing that, I'm curling that information into the SDN controller. So this is basically the TCP connection information on the console. This is the file that I wanted to show you, where I'm basically grabbing that same information and I'm echoing that into the a.txt file, which is sitting in here. So I'm basically using that command, saving it into the default web server directory, and then I'm downloading that file constantly every 2 seconds into the SDN controller. So that way I have a sense of how many TCP connections. And you don't have to do TCP, you can do anything you want, but basically TCP connection is what a lot of people look at from a load balancing perspective, so that they have a sense of what the load is on these web servers, and you program it, and then you can look at the packet load on each router if you have multiple routers and program it. So this is obviously this set, the routers and the controller needs to be in BGP AS2. You can look at the video of ExaBGP that I have in terms of how to configure this guy. And there, once you bring it up, it's pretty straightforward. I'll show you the script that you may have to run for this guy to come up once you follow that ExaBGP video. So, and the script to bring it up is this guy, start ExaBGP. Once you bring the ExaBGP controller up, you can put this into a startup file or a script to start it, and then basically the script says make FIFO in this directory, change the permission on it, and then change the owner on it, and then run the ExaBGP software with this config file, which is right here. It's very simple. You're peering with this router right here. SDN is peering with this guy, 1112. Just put a router ID of whatever it is, your interface address, local address, local AS is 2 for SDN controller as well, and the peer address is AS2 as well. That's it. Once you configure this conf.i, and then you run this command, it'll start running in the background. You have to do these each time it starts. So make a script, and then all you got to do is start ExaBGP, and it'll go in the background running. Hope this SDN Lab setup gives you a perspective of what a software-defined networking is. It not only talks to the application, but it also talks to the network to make or program the network according to the application. Hope this helps.